To today's lecture. So tonight we're still looking at polynomials, and under polynomials we are going to be discussing the factor theorem and the remainder theorem. Okay, so this is a very simple topic. So I'll start first by introducing what a polynomial is, and then we'll go bit by bit. We'll be getting into details bit by bit. So a polynomial is simply just any function that is in the format, and it is usually denoted by p of x. Then this format is the one that represents a polynomial. So polynomials are simply just functions that have a degree that is higher than 1. So this implies that even a quadratic equation is a polynomial with a degree 2, because we know that a quadratic equation is in the format ax squared plus bx plus c is equal to 0. So this is an equation which has a degree 2. So a polynomial is a function that has a degree which is 2 and above. Yeah, so let us look at the factor theorem. You know why it used to be. Okay, so if you have been given a polynomial p of x, then they've told you to divide that polynomial by a certain p of x with a degree n, then they've told you to divide that polynomial by a certain linear function. So how do you do that? So you first equate that linear function to 0. So we're going to say x minus b is equal to 0. Then you say x is equal to, you take negative b to the other side of the equal sign, you say x is equal to b. So when you find p of b, the answer that you are going to find is the one that we call the remainder. So if p of b is equal to 0, if after replacing b in the polynomial that we've been given, let's say for instance x squared plus bx, or let me say x to the power 3 plus bx plus cx plus d. So if this is your polynomial that you have, then you've been told to find the remainder when you divide this into this polynomial. So after replacing this b while there's x there, if you get any answer, let's say you get maybe you get 3 as the answer, it means that the remainder is 3 when you divide this into any given polynomial, into that polynomial. And then if the answer is 0, it means that the remainder is 0. And every time you find a remainder 0 after dividing two numbers or two functions, it means that the given linear function there is a factor of that polynomial. So a factor is simply just a number that can go into another number without leaving a remainder. Okay, so imagine that you have a polynomial, let's say px, and then you divide this px by a certain function d of x. The answer that you are going to get will simply just be the quotient, which we are going to call q of x, and then plus the remainder which is just r of x, and then divided by d of x. Where do I get this expression? Imagine you have 7 and you're dividing 7 by 2. When you say 2 into 7, the answer that you are going to get is 3, and then remainder 1 over 2. So this can also be written as 3 plus 1 over 2. So this is the case even for functions. So the quotient, meaning what you have found there as your answer, you write it there, and then you say plus, and then the remainder you write it on top, and then divide, and then you put the divisor down there, which is 2 in this case. Alright, so let's look at one of the examples. Right. Okay, so what I was explaining is this. In this expression, you have p of x, which is just the dividend, then you have d of x, which is the divisor, then you have the q of x, which is the quotient, the answer, then you have r of x, in this case is the remainder. So it's not always that the remainder will be a constant or just a number, no. Sometimes the remainder can be 2x. So when you start doing calculus, you discover that most of the answers that we're going to be finding after dividing, when the time we start applying this concept of division of functions in calculus, the answers that we'll be finding will be in this format. What does that mean? Okay, in short, this is used to find the slant asymptotes. On the part of finding the horizontal vertical asymptote, but using calculus, you can also find the slant asymptote and the horizontal asymptote using limits. So we're going to discuss that. Alright, so we have, this remainder and factor theorem can help you factorize the function that we've been given. If the polynomial p of x has been given, you can easily factorize it using the remainder and factor theorem. You can also solve the inequalities, polynomials that are inequality format. And then you can also, this same remainder and factor theorem can also help you to plot the functions, to plot the graphs of polynomials, which we're going to do at a later stage. Okay, let's look at this example. The example is find the remainder when p of x is equal to that, is divided by x minus 1, and it's also divided by that. So remember what I said? I said you just have to equate what you've been given, the linear function, to 0. So when you equate that to 0, you're going to have x plus, this is x minus 1 rather. So we're going to have x minus 1. Okay, let me just erase this. Okay, so we have this, and then we say we divide it by that. So we equate x minus 1 to 0. We have x minus 1. We equate that to 0. Meaning the value of x will therefore be equal to positive 1. So I'm going to find, I'm going to replace this positive 1 in the whole equation. The answer that I'm going to get is the remainder. Remember what I said? I said if you find p of b using a polynomial, if the answer, if you have any answer this side, that answer is the one that we call the remainder. If you have 0 there, it means that the given function is a factor. Alright, so let us replace 1 while there's x there. So we find p of 1. So p of 1 there will be 1 cubed. We have minus 1 squared minus 1, then plus 1. So when we do the simplifying there, we have 1 minus 1 minus 1 plus 1, which is just going to give us a 0. So 1 minus 1 plus 1, the answer is 0. So now what this means is that this given expression is a factor of this polynomial. Why? Because the remainder that we were expecting to be a number or a function is 0. So let us try to divide this into that to see if it's going to have a remainder. So if we divide that, it's just the same as finding, first equating x plus 2 to 0. So when you equate x plus 2 to 0, you have something like x plus 2 is equal to 0. Then you take the 2 to the other side of the equal sign, so you have x is equal to negative 2. So from there now, we can just replace this negative 2 in the polynomial there. So we find p of negative 2. Then when you find p of negative 2, the answer will be negative 2 there. Then we say cubed minus, we put negative 2 there, squared, we have minus, we have negative 2 there, and then we have a plus 1 there. So p of negative 2 will therefore just be equal to, so this one will give us negative 8. Then here we're going to have minus 4, then we have plus 2, we have plus 1 there. So when you add these two, you are going to get negative 12. Then when you add 2 and 1, you get positive 3. So when you add negative 12 and positive 3, you get a negative 9 as the answer. So this negative 9 is the remainder when you divide this polynomial by x plus 2. This is the answer. So this is not the only way you can find the remainders. Imagine you've been given to, imagine if this, if what you've been given here is not a linear function. Imagine you have a quadratic function there, plus 2x plus 1. Then they tell you to say divide this polynomial by this quadratic function. What are you going to use? So this is now where we use what is called the long division method. The same long division that we learned from grade 5 to 12 is the same long division that we're going to be using to divide polynomials. To divide functions into a polynomial. Alright, so this is what we're going to use. We're going to be using long division. Apart from long division, you can also find the same remainders using what is known as synthetic division, which is also slightly simpler than long division. So let us see how we can use synthetic. Okay. Alright, so we have this question here. We have this question on the screen. We have this question here. Then the question is, determine whether x minus 1 is a factor of this polynomial here. If not, find the remainder. So in this case, I'm not going to use the first method, which I'm just from showing you. Let me use what is known as synthetic division. So synthetic division, you equate the given linear function to 0. So we say x minus 1 is equal to 0. Then we find the value of x to be 1. So we're going to draw this table. Then we'll put in this table the coefficient of, all the coefficients that are in this polynomial. So the first coefficient that we have is 1, the coefficient of x to the power 3. The coefficient of x to the power 2 is 3. The coefficient of x is another 3 there. Then we also have the constant 1. So we also have to include it there. Then we are going to put this 1 there. So the first thing, we're going to bring down this 1. So we're going to say 1 plus, we don't have anything here. So 1 plus 0, the answer is 1. So when we multiply this 1 times this 1, the answer will be 1. So when you add 3 plus 1, the answer is 4. When you multiply 1 times 4, the answer is 1 times 4, the answer is 4. When you add 3 plus 4, the answer is 7. When you multiply 1 times 7, the answer is 7. When you add 1 plus 7, the answer is 8. So whatever that you are going to get here is the remainder. So this one down here represents the coefficients of a quadratic equation, or it represents the coefficient of the resulting equation, or the quotient in short. So the first one here, if the highest power was 3, it means that the first one here, the first number, the first digit, the first number here, or the first coefficient will be the coefficient of x to the power 2. So if we had x to the power 3 there, the first one here will be the coefficient of x to the power 2. So I'm going to write it like this. I'm going to have the first one will be x to the power 2. This is the coefficient, which is 1, so I can write it or not, still the same. Then we have the coefficient 4 there. So we have plus, it's positive 4, so I'll say positive 4. This will be the coefficient of x. Then we have 7, which is just the constant there. So the resulting expression here in this case is a quadratic equation. So if we had x to the power 4, while there is x to the power 3 there, this first power would have been x to the power 3. If this was x to the power 4, this would have been x to the power 3. If this was x to the power 5, this would have we would have started with x to the power 4. Yeah. So this is the quadratic equation, and then so after dividing this by that, we have the remainder 8. So the quotient, which is qx, so the quotient qx is equal to this, and then the remainder that we have found now, the remainder is simply just 8. So they are saying if this is not a factor of this expression, meaning after dividing this, if it doesn't give us a 0, we should find the remainder. So it never gave us 0. How? By checking what is here. So if the answer that was here was a 0, would have said it's a factor, and the remainder would have been a 0. But in this case, it's not a factor because the remainder is 8. Let's look at the other question. So the second question is this one. It says divide x to the power 4 plus 3 by x minus 2. So we can use another method that is long division. So the first one, this one, I used synthetic division. Now let me apply long division. So applying long division, okay, let me start with this same first question here, using long division. So how do we solve this one using long division? So long division, we know the format is always like this. So we have x to the power 3 there, then plus, I'm trying to cover 3 things at once. Then we have plus 3x then plus 1. So let me divide this by that, and you see if we're going to get the same remainder as the one that we got using synthetic division. So we have x minus 1. So x into x cubed, the answer is x squared. X squared times x there, the answer is x cubed. X squared times negative 1, the answer is negative x squared. Then when we subtract, they are going to have this minus that, the answer is 0. Then 3x squared minus negative x squared. So we have 3x squared minus negative x squared. So negative times negative, there will be a plus there. We're going to have a plus. Then we have 3x squared there. So when you add the two, we're getting 4x squared. So we're going to put a positive 4x squared there. So this x into 4x squared, the answer is positive 4x. So when you multiply 4x times 4x, 4x times x there, we get 4x squared. Then we have a plus 3 there, which we can just bring down. And then this 4x times negative 1. So this 4x times negative 1, the answer is negative 4x. So in case you are wondering where I've gotten the positive 3x, it's just this one here. So we do this and then we subtract. So 4x squared minus 4x squared, the answer is 0. Then 3x minus negative 4. So we say 3x minus negative 4x. The answer will be 3x. Negative times negative will give us a positive plus 4x. So this one will give us what? 7x. So we have positive 7x. So we're going to bring down the 1 there. So we're going to have 1. So this 3 is the one that is there. Then we bring down the positive 1 there. So we divide x into 7x. The answer is 7. 7 times x, we have 7x. And then 7 times negative 1, we have negative 7. Then we subtract. So 7x minus 7x, 0. 1 minus negative 7. So 1 minus negative 7. The answer is 1 plus 7, which gives us 8. So we have positive 8 here. So when you look at what we have found here, this is the remainder. So if you remember in synthetic division, this is the quotient that we got. If you are able to recall the answer that we got, this is the quotient that we got, and this is exactly the same remainder that we got. So you can use any formula, provided you have just followed the right steps. The answers will just be the same. Okay, so this is how we use long division. So let us now use synthetic and long division on this one. Then we call it a day. Okay, so let us now we were on the second one here. We solve this one, we divide this one by this one using synthetic and long division. Let's see the answers that we're going to get if they'll be the same. So using synthetic division, we equate x minus 2 to 0. We're going to have x minus 2. We equate this to 0. So these two will cross the equal sign, meaning we're going to have x is equal to positive 2. So using synthetic division, we're going to have this. So this one, we're not going to use it the way it is. We're going to rewrite this. So we have x to the power 4. Then we have plus 0x to the power 3 plus 0x to the power 2. We're going to put placeholders in between. Then we have plus 0x and then the constant, which is 3. So we have 1. Then we have how many zeros? 1, 2, 3. We have 1, 2, 3 zeros. And then we have a constant. So we have a number here which is 2. It's the one that we're going to put there. So the first thing, we add 1 plus 0 here. The answer is 0. Rather, the answer is 1. Then 2 times 1, the answer is 2. 0 plus 2, the answer is 2. 2 times 2, the answer is 4. 0 plus 4, the answer is 4. 2 times 4, the answer is 8. 0 plus 8, the answer is 8. 2 times 8, the answer is 16. And then we have 3 plus 16, the answer is 19. So the remainder in this case is 19. So the resulting quotient here is So the quotient that we have found is simply just q of x, which will be this will be x to the power, this is a constant, x squared, x to the power 3. Look at here, we have x to the power 4, so the first one will be x to the power 3. Then we have the second constant, there will be the coefficient of 2, the coefficient of x squared, then followed by the coefficient of x, and then the constant at the end there. So this is the quotient, and the remainder is 19. So if you want, you can use the remainder and factor theorem, where you just replace these two while there is x there to find the remainder. So the remainder will simply just be 2 to the power 4. Let us just prove if at all we're going to have the same answer. So 2 to the power 4 plus 3. So 2 to the power 4, the answer is 16. So 16 plus 3, the answer is 19. So we can see that even after replacing that using the factor theorem, the answer is still going to be 19. The remainder will still give us 19. Alright, let us now use long division. So we are going to use long division to solve the same question. Okay, so the first thing, we write this expression using it by putting in the placeholders. So we have x to the power 4, then we have plus 0x to the power 3 plus 0x to the power 2 plus 0x and then plus 3. So we are going to put this in the long division. So we have x to the power 4 plus 0x to the power 3 plus 0x squared plus 0x plus 3. Then we put x minus 2 here, x minus 2. So we divide x into x to the power 4. We have x to the power 3 there. So when we multiply that and that, x to the power 3 times x, we get x to the power 4. X to the power 3 times negative 2, we get negative 2x to the power 3. Then we subtract. So this minus that, the answer is 0. This minus that, the answer is positive 2. So you can be doing a simple subtraction like the ones I was doing here that time. So we say x into 2x, the answer, oh rather this one is supposed to be x to the power 3. X into 2x to the power 3, the answer is 2x to the power 2. Then when we multiply these times x, we get 2 to the power 2x to the power 3. Then of course we bring down this 0x squared. Then 2x squared times negative 2, we get negative 4x squared. Then we do this, we subtract. So when we do the subtraction, we get here on this part will give us a 0, but this part will not give us a 0, it will give us a positive 4x squared. So we say x into x squared, 4x squared, the answer will be 4x. When we multiply 4x times x, we get 4x squared. Then when we multiply 4x times negative 2, we're getting negative 8x. And then we bring down this 0. We have positive, we have a 0x there. So if we subtract, this part will give us a 0, this part will give us positive 8. And then from there we can now positive 8x rather. So we have x into 8x, the answer is 8. So 8 times x, we have 8x, and then 8 times negative 2, we have negative 16. Then here we bring down the 3, we have positive 3, and then we subtract. So when we subtract this part will give me a 0. Then this part will have 3 minus negative 16. So we have 3 minus negative 16. So this is just the same as 3 plus 16. The answer, which will be 19. So this is positive 19 is the remainder. So whether you use the factor theorem, you use the remainder and factor theorem, you use the, if you want, you can use, let me do this. Unfortunately, everything has erased. Okay, so I was trying to make a point to say whether it doesn't matter what formula you use. You can use the remainder theorem, you can use the quotient, you can use the remainder theorem, you can use long division or synthetic division. The answer will still be the same. So you don't have to stress or to do assist to even use a long method if you know a short method of finding a remainder. So if the question is just asking you to find the remainder, just use the remainder and factor theorem. But if they also want to use the quotient, or if you have also been told to use the quotient at some point in the question, make sure that you use long division or synthetic division. So long division is like a universal way of dividing functions, because synthetic division cannot divide functions. Let's say you are dividing this function. You're dividing this function by, let's say, x squared minus 2x. You can't divide this function by this polynomial by this function using synthetic or remainder theorem. The only way you can divide this by that is by using long division, where you do this, you put in that expression there. So after putting in that, and then you put your function there, which is x squared minus 2x, then you begin to divide x squared into that, you get x as your answer. X times that, you get x to the power 3. So long division can work if you want to divide such a function. Alright, so this is the end of today's lecture. You can see my laptop is performing today, I don't know why. So we will meet in the next lecture that we're going to have, where we're going to discuss how to find the roots of a polynomial. And then apart from finding the roots of a polynomial, we also have to discuss how to factorize polynomials using trial error method. And then apart from that, we'll also discuss how to sketch the graphs of these polynomials. So don't miss the next lecture, it's going to be interesting. My name is Harmtedy. See you in the next lecture. Shalom, shalom.